Section 4.2, Maximum and Minimum Values. Some of the most important applications of differential calculus are optimization problems, in which we are required to find the optimal, meaning the best way of doing something. Here are examples of such problems that we will solve in this chapter. What is the shape of a can that minimizes manufacturing costs? What is the maximum acceleration of a space shuttle? This is an important question to the astronauts who have to withstand the effects of acceleration. What is the radius of a contracted windpipe that expels air most rapidly during a cough? At what angle should blood vessels branch so as to minimize the energy expended by the heart in pumping blood? Now, these problems can be reduced to finding the maximum or minimum values of a function. Let's first explain exactly what we mean by maximum and minimum values. We see that the highest point on the graph here to the left, this function, is the point 3,5. So here is that point, which is located at 3,5. So in other words, the largest value of f is f of 3 is equal to 5. And likewise, the smallest value is f of 6, which is equal to 2, which represents this order pair, 6 and then 2. And then we would say that f of 3 equals 5 is the absolute maximum of the function f. And we would say that f of 6 is equal to 2 is the absolute minimum. So in general, we use the following definition. Let C be the number in a domain D of a function f. Then f of C is the absolute maximum value of f on D if f of C is greater than or equal to f of x for all x in the domain. And it's an absolute minimum value of f on the domain if f of c is less than or equal to f of x for all x in the domain. Now, an absolute maximum or minimum is sometimes called a global maximum or minimum. The maximum and minimum values of a function are called extreme values of the function. This next figure shows the graph of a function f with absolute maximum at the value of d. So here is the absolute maximum. And then we also have an absolute minimum at a. So here is the lowest point on the graph, so therefore that's going to represent the absolute minimum. Now, note that d, f of d, is the highest point on the graph, and a, f of a, is the lowest point on the graph. Now, also in the figure, if we consider only values of x near the value of b, so for instance, if we restrict our attention to the interval that's in between a and c, then f of b is the largest of those values of f of x. And so therefore, that is called a local maximum of that function. And likewise, f of c is called a local minimum of a value of f because f of c is less than or equal to f of x near for x when it's near c. So this is the local minimum. Now, and again, that's in the interval between b and d. Now, the function f also has a local minimum at the value of e. So you can see here, there is another local minimum. So just to review here, this is the absolute minimum because this is the lowest minimum on that graph. And that's why these are local minimums. These two are peaks. This is the absolute maximum because that's as high as the graph goes, and therefore that's the local max. So the definition, the number f of c is a local maximum value of f if f of c is greater than or equal to f of x when x is near the value of c. And it's a local minimum value of f if f of c is less than or equal to f of x when x is near c. Now in definition 2 and elsewhere, if we say that something is true near that value of c, we mean that it is true on some open interval that's containing the value of c. So for instance, in this figure here, okay, we see that f of 4 at 5 here is a local minimum because it's the smallest value of f on the interval I. So this is the interval of I, and that is the smallest value. But it's not the absolute minimum because f of x takes on smaller values when x is near 12. And that's in the interval of k. So for instance, therefore, in fact, 12, 3 is both a local minimum and the absolute minimum. And similarly, we can look at f of 8 of 7 is a local maximum, but not the absolute maximum because f takes on larger values near 1. So we can see here that this would be the absolute maximum. So this would be considered the absolute maximum. And again, this is the local and absolute minimum over here.